Today we will discuss about 21 chapter trigonometrical identities. First of all, what is trigonometry? Trigonometry means three sides measurement or three angles measurement. Today we will discuss about trigonometrical identities. Trigonometrical identities also we can apply on right angles triangles. Right angle triangle. A, B, C. Right angle triangle means one angle compulsory 90 degrees. This is 90 degrees. Remaining two angles sum is 90 degrees. Because A, B, C, this is one type of triangle. In a triangle, sum of all angles are 180 degrees. One angle 90 degrees means remaining two angles compulsory less than 90 degrees it will come. Let us discuss about trigonometry. Here 90 degrees. 90 degrees opposite side we can call hypotenuse. Next, theta either here or here. We have to consider. Suppose theta, if you will consider here, theta opposite side, we can call perpendicular side. Perpendicular side. And one more side is adjacent side. Theta adjacent. These three sides we can use and we can find out trigonometric identities and trigonometric ratios. First, we have to discuss trigonometric ratios. Trigonometric ratios means the ratio between a pair of sides. There are 6 trigonometric ratios: sine, cos, tan, cosecant, secant, and cot. Here one angle we have to need. But what angle we have to consider? Theta, where we have to consider that angle we have to write there. Here theta is at A. So sin A we have to write here. Sin A is equal to, what formula we can apply here? Sin A means perpendicular side by hypotenuse it will come. What is the perpendicular side here? BC is the perpendicular side and AC is the hypotenuse. Perpendicular side by hypotenuse is equal to, what is perpendicular side? BC. BC by AC. Next, cos A is equal to, here cos A means adjacent side by hypotenuse. Adjacent side by hypotenuse. What is the adjacent side from the diagram? AB is the adjacent side by hypotenuse, AC. Tan A. Tan A means a perpendicular side by adjacent side. Adjacent side. Cosecant A. Cosecant A means reciprocal of sin A. Sin and cosecant are reciprocals. So cosecant A is equal to 1 by sin A we can write. 1 by sin A. Sin A formula is perpendicular side by hypotenuse. 1 by sin A means reverse order we have to write. Hypotenuse by perpendicular side. Next, secant A. Secant A and cos A are reciprocals. So, secant A is equal to 1 by cos A we have to write. 1 by cos A means how to write? Here adjacent by hypotenuse, that is cos A. Here secant A, reverse order, hypotenuse by adjacent. Hypotenuse by adjacent. This is secant A. Next, cot A. Cot A and tan A reciprocals. 1 by tan A we can write. 1 by tan A. Tan A, perpendicular side by adjacent side. Cot A, adjacent side by perpendicular side. These are the trigonometric ratios. Next, we have relations between the sine and cosecant. Cos, secant. Tan, cot. Already we discussed here. Cosecant, sine reciprocals and secant, cos reciprocals. Cot and tan are reciprocals. and relation between the sine, cos, tan. Tan A. We have to write in terms of sine and cos. We have one formula. Sine A by cos A. Cot. Cot A means these two are reciprocals. Tan is sine by cos means cot means cos by sine A. Cos A by sine A. These are the relations. Next, coming to our topic, trigonometric identities. We have three trigonometric identities. The three trigonometric identities are, first one, sine square theta plus cos square theta is equal to 1. This formula we can write in different ways. First, sine square theta is equal to cos square theta, we have to send right side. 1 minus cos square theta. Next, cos square theta is equal to, now right sine square theta we have to send right side. 1 minus sine square theta. So, same formula we have to write in different ways. Next, second identity. 1 plus tan square theta is equal to secant square theta. Third one is 1 plus cot square theta is equal to cosecant square theta. These three are identities. These formulas and all we can use and we can find out exercises. Next, exercise 21A. First problem, sin power 4 theta minus cos power 4 theta. How to solve this problem? First, power 4. We have to change that. Sin square theta whole square 2 to the 4. Cos square theta whole square. Here like a square minus b square formula. What is a square minus b square formula? A square minus b square is equal to a plus b into a minus b. This formula we have to apply here. Here a sin square theta is a. Cos square theta is equal to b. Where is a and b? We have to substitute sin square theta and cos square theta. Plus b and a minus b. Sin square theta plus cos square theta. Use identities. What is the identity here? Sin square theta plus cos square theta is equal to 1. This value is 1. So first bracket value is 1. Second bracket, sin square theta minus cos square theta. We should apply this problem. Cos square theta plus what we can write? 1 minus. Here sin square theta shifting means minus sin square theta. Instead of cos square theta plus, we have to write 1 minus sin square theta. Here 1 minus into minus plus sin square theta. Here sin square theta, sin square theta. How many times? 2 times. So 2 sin square theta minus 1. Sin power 4 theta minus cos power 4 theta value is 2 sin square theta minus 1. Hence proved. A. Next problem B. 1 plus tan theta whole square, 1 minus tan theta whole square. Here we have to apply a plus b whole square formula. Here a minus b whole square formula. What is a plus b whole square and a minus b whole square formula? A plus b whole square. A square plus b square plus 2ab. A minus b whole square formula. A square plus b square minus 2ab. These two formulas we have to apply in this problem. First bracket, a plus b whole square. 1 square plus tan theta whole square plus 2ab. So 2 into 1 into tan theta. This is first bracket. Next second bracket, 1 minus tan theta means a minus b whole square. 1 square plus tan theta whole square minus 2 into 1 into tan theta. Here 1 square value 1 into 1. 1 plus tan theta whole square. tan square theta plus 2 into 1, 2 into tan theta, 2 tan theta. Here plus 1 square, 1 plus tan square theta minus 2 tan theta. Here minus 2 tan theta plus 2 tan theta cancel. Remaining 1 plus 1, 2 plus how many tan square theta? 2 tan square theta. 2 tan square theta. What is the common? 2 is the common here. 1 plus tan square theta. We have one formula here, identity. 1 plus tan square theta formula. 1 plus tan square theta is equal to secant square theta. Instead of 1 plus tan square theta plus secant square theta, we have to write 2 secant square theta. Hence proved. Next problem is C. Here cot power 4 theta plus cot square theta. What is the common here? Here 4 times cot theta, here 2 times cot theta. So cot square theta common we have to take. Cot square theta. Remaining here 4 total 4. Here 2 I took common. Remaining 2. Cot square theta plus here cot square theta common. Remaining 1. Here cot square theta, how to write? We have identity. That identity we have to use. Cot square theta plus 1 is equal to cosecant square theta. Here cot square theta we need. Cot square theta is equal to plus 1 shift right side. Cosecant square theta minus 1. Instead of cot square theta plus cosecant square theta minus 1, we have to write. Next, cot square theta plus 1. Cot square theta plus 1 plus cosecant square theta we have to write. Here, cosecant square theta minus 1. Here, cot square theta plus 1, cosecant square theta. These two you should multiply. Cosecant square theta into cosecant square theta. Cosecant square power 4 minus 1 into cosecant square theta. Cosecant square theta. Hence proved. Next problem D. 1 minus 1 by 1 minus sin A. This value we have to find out. Here denominator rationalizing we have to do. How to do denominator rationalizing? 1 minus sin A into, here minus means plus we have to multiply and divide. 1 plus sin A by 1 plus sin A. Numerator we have to multiply. 1 into 1 plus sin A. 1 plus sin A by, here A minus B, A plus B. A plus B into A minus B formula we have to apply. A square minus B square. Instead of A plus 1. Instead of B plus sin A. So A square minus B square. 1 square minus sin square A. Here 1 plus sin A by 1 square means 1 minus sin square A. 1 minus sin square. Identity. Sin square A plus cos square A is equal to 1. Here we need 1 minus sin square. So cos square A is equal to 1 sin square shifting right side. Sin square A. Instead of 1 minus sin square A plus cos square A, we have to write cos square A. Separate I will write here. 1 by cos square A into 1 plus sin A. 1 by sin square A. Reciprocals of cos sin. Cos is equal to, cos A equal to 1 by secant A we can write. Already we did formulas under. So 1 by cos square A plus secant square A we can write. Secant square A of 1 plus sin A. Hence proved. Next problem is E. Tan square A by secant A plus 1 whole square. Here tan square A, we have identity. 1 plus tan square A is equal to secant square A. Why we are using this formula? denominator secant A term is there. So numerator also we have to change in terms of secant. Here tan A, tan square A is equal to 1 shift right side, secant square A minus 1. We should write that formula. Secant square A minus 1 by secant A plus 1. Denominator as it is, we should write secant A minus 1. I will write here secant A whole square minus 1 whole square. No changes. Secant A plus 1 whole square. Here A square minus B square formula we can apply. A square minus B square formula. A plus B into A minus B. Instead of A plus secant A, instead of B plus 1, we have to write secant A plus 1, secant A minus 1 by, here secant A plus 1 whole square, 2 times is there. So separate I will write here secant A plus 1 into secant A minus 1. Here numerator cancel, it will go. Here secant A, how to write? 1 by cos. Cos and secant are reciprocals. 1 by cos A plus 1 by 1 by cos A. Here secant A plus 1, secant A minus 1. Here, sorry. This formula we can apply here. Instead of A plus secant A, instead of B plus 1. Secant A plus 1, secant A minus 1 by denominator secant A plus 1 whole square. 2 times is there. So separate I will write here secant A plus 1 time, secant A plus 1 2 times. Here cancellation, secant A plus 1, secant A plus 1 cancel. Here secant A, cos secant reciprocals. So secant A is equal to 1 by cos A we can write. 1 by cos A minus 1 by 1 by cos A plus 1. Here numerator LCM and denominator LCM we have to take. Here LCM, numerator LCM and denominator LCM we have to take. Cos A, here 1 minus cos A by, here denominator LCM, cos A, here cos A plus 1. Here denominator cancel, remaining. Here 1 minus cos A by 1 plus cos A. Hence, proved.